40.4 40.4 40.4 40.4. Okay, welcome to 40.4. My name is Sean Winters. 40.4 is an audio-forward intermedia sonic summit hosted by B2 and the Atlas Institute, University of Colorado Boulder. Huge thanks to our sponsors, B2, the Department of Critical Media Practices, and Cycling 74. Also, thanks to our partners and collaborators this year, Anton Bruckner Private University in Linz, Austria, Ars Electronica, and LEAF, the Lafayette Electronic Arts Festival. So this afternoon, we will be talking about hybrid audio diffusion systems with Enrique Mendoza. The festival is in its third year. Why 40.4? There are 44 speakers in this room hanging on the walls, 4 rows, bottom row speakers, second row, third row on the grid, and then speakers on the ceiling, and then 4 subwoofers, so 40 speakers, 4 subs, 40.4. Thank you to Critical Media Practices Department and B2 for sponsoring this talk. Special thanks to Undine Geary, August Black, Chris Patillo, Brett Mann, and John Gale at B2, and big thanks to Mark Gross at Atlas and Reese August at DCMP for their support with this endeavor. I do think it's maybe a good moment to show something from this session that we'll be using. So on the poster we have these headphones. Cole, would you mind coming up here? Popping these headphones. We did a workshop on Monday in the BTU lab where we 3D printed and assembled these headphones. Cole was there helping out, so thank you for modeling them for us. Yeah, we did an event on Monday at the BTU lab where we were assembling these headphones, and these are a type of open headphone. Yes, this is what we're going to be using for this presentation, so Enrique will talk about that a little bit more, but these are open source, available to be 3D printed and used for this type of endeavor. Real quick intro about Enrique, and then we'll get this rolling. So Enrique Mendoza, born in Mexico City and based in Vienna, is an artist focusing on electroacoustic composition, live electronics, and hybrid live diffusion using Ambisonics, binaural and discrete system techniques. His electroacoustic compositions and performances use DIY analog oscillators, lo-fi mini synths, custom software, 3D immersive music technology, and multi-channel systems. Enrique is currently a researcher at the Anton Bruckner Private University in Linz, Austria. And just in general, if you have a chance to say hi to Enrique, very, very friendly, wonderful person. We are so happy to have him here at B2 at the Atlas Institute in lovely Boulder, Colorado. So please welcome Enrique Mendoza.
Thank you very much. Okay, so let's start. So, well, thanks. Thank you very much, Sean, also John, Chris, everybody for helping me for the setup. Amazing place. I'm so happy to be here. Also for the workshop on Monday. It was really cool, guys. And I'm very happy to have you here. So I will be talking about the hybrid audio diffusion system and the concept of creating augmented sound fields. So the best is to listen, right, to then know what are we talking about. So I will just tell you very fast a little bit of idea, and then we start listening some examples. So the idea of the hybrid diffusion system is that I am combining the open headphones. So if you put them on, let's do it. Left, left, right, right. Normally the cable goes in the left side in this. So now you can still listen to me, right? Almost perfectly. You can hear a little bit of filtering, but that's the idea. So when I also set up the speakers and then there is sound from the speakers, you will still get it in your ears. Of course, I am combining a theoretical sphere of sound in the speakers and another sphere of sound in the headphones. So I will put a first example that is maybe a peculiar piece because it's just made with sine waves to try to test the system, let's say. But now that we are here, small family together, let's do a little bit more tests. So for example, so you can see what is happening. So the first thing is that I will put only the headphones, right? So there it goes. Okay, so we are listening these rising waves. And now I will add the speakers. And now I will remove the headphones. Again together. Cool. I will do shorter examples so we can listen more examples, no? But now, for me, it would be interesting to hear what you have to say. Like, what did you perceive now? Did you perceive some movement? Did you perceive things that were kind of distributed in space? What was this tiny experience of it? What can you say? Yeah.
I wanted to ask this question.
Yes.
Earlier. I wanted to hear the shepherd tone, which is the, it's basically like an optical illusion for audio where something's always lifting and something's always like descending.
Yeah.
And never hits bottom. I kept wanting to hear that, or my brain was that part of it, or just, was it just?
Yeah, everybody tells me about, are these shepherd tones? But it was exactly not shepherd tones, but gives that impression because, yeah, there is always some sine waves going up and there is one or more sine waves going down.
I mean,
Yeah.
it sounds like a shepherd tone deconstructed and separated and spatially.
Exactly.
As opposed to all, just.
Yeah,
So
yeah,
that
yeah.
was my spatial experience with the shepherd tone.
Totally. But so, what else, guys? Did you perceive the sound was moving, for example, a little bit of movement?
Yeah, I felt like it was kind of surrounding me.
Yeah.
Like it felt like it kept getting closer. So I definitely felt movement within the sound.
Mm-hmm. Yeah, and well, actually, somebody else? Because actually, this is my first case study of the research, and that's why I was also using the sine waves. Normally, the tests for audio are made with sine waves because then we don't have a timbre, right? That can they are full of cultural context. No, if we hear an instrument, a violin or a djembe or a steel drum, then you just feel in like Central America, right? So, and it was to prove we were listening exactly the same inside and outside. But so just by combining the system with this case study, I could prove that is bringing this extra movement perception kind of, because actually there was no movement at all. So just by the combination, it starts to create this kind of a very nice phenomenon, I think. So let's dive into it. So a little bit of the concept of this, what is happening is that we have one sound field, a 3D sound field, fixed to the head. So that would be the egocentric frame of reference. So it's fixed because it doesn't matter where I move, it's following me, right? To move that, then we will have to do head tracking. But for this project, actually it's better without the head tracking to create this. The other second sound field is fixed to the room, acoustics, to the speakers, and that doesn't move. So if I move my head like this, the sound stays. And then it starts to creating these inconsistencies between what I have inside and what I have outside. So it's the egocentric frame of reference against the allocentric frame of reference. And then these headphones by themselves are awesome, no? And binaural renders are really cool. And also the 3D with speakers. But both have amazing qualities, but they also have limitations. For example, in the headphones, it's very hard to have the perception that the sound is really in front of you. Like when you are listening with a stereo, no? You have your two speakers and it's clearly that the sound is coming from there. When you translate that to headphones, it gets distorted. It gets like a ooh, right? It's like this, like if you are listening, I don't know, Bob Marley in your headphones, the voice is not here, it's more a little bit here, right? So that's one of the limitations of the headphones. It's being now more and more researched with maybe time effects, with delays, with reverb. We can create this impression that it is really, but it's hard. So, but for example, one of the advantages is the sweet spot. With the headphones, doesn't matter where you are in the room, and even if you move, you are always in the sweet spot. That's, for example, a limitation of the speakers. Now, the sweet spot in this place is here where you are, kind of around, but so if there is a lot of people and I am sitting there, well, I am too close to that speaker and too far from that. So then that sweet spot is modified. So we cannot control that. Another thing is that with headphones, it changes the experience because we are not getting the sound waves, like the physicality of getting the energy. Sound is energy moving in an elastic medium, right? So we don't get that. No? And for example, especially for me that I love bass, with the subwoofers, you can have that frequency on the headphones, but you don't feel like the super nice experience of having bass, right? So that's why, and also normally composers and artists go all the way for headphones or all the way for speakers, but never combine. Actually, at the beginning, I thought maybe this is a very dumb idea. Nobody has done it. So, or, yeah, I don't know, no? But then I pursued it and it was cool. Actually, a lot of, when I do workshops and lectures, a lot, yeah, I have the idea, but well, nobody pursued it until I did, no? Because I really researched for the PhD, you need to put the state of the art, who else has done stuff, and I couldn't find anything about somebody combining them, no? It's normally one or the other. So, and then all the project is about composing and perceiving this augmented 3D immersive sound field that I create with going inside your head to the speakers and back. We can create this idea. So a little bit of the technology, and then we will listen some examples. Sorry, is of course one of the main things is Ambisonics. That how acquainted are you with Ambisonics? More or less. So I will explain very fast. Maybe a little bit first with this slide. So Ambisonics, I like this definition. Is a system for recording, synthesizing, and monitoring or reproducing this sphere of sound. So, something very nice and important is that it's not attached to any channel number, in opposition, for example, like a 5.1 for movie, 7, or even Dolby Atmos, is fixed to the speakers you are working with. So when you move that movie, let's say, and then you take it to another theater, the speaker is supposed to be in the same spot, they have to be in the same angles, so you can recreate what the producer did. But with Ambisonics, we can change this. So we have first, let's say this first column is where we record or we create our sound sources. And we can combine mono, stereo, or even ambisonic sources, like this microphone that is here flat. It's an ambisonic mic. So if you put it apart, they have like different capsules at the same time looking in different directions, and so it's capturing everything. So we could combine all these different type of sources and then encode them. We need to have like these two encoding and decoding process for Ambisonics. The encoding is a fancy word to say panning, right? It's the panning moment. No? We can do that even with stereo. So then we synthesize, we combine all these sources in our sphere of sound, but then we need to decode it. And in that case, I can send it to any type of monitoring. So for example, something very cool is that you can work at your place with your laptop, with your headphones, and then come to this place and listen what you did. Of course, we need to have our imagination, but that's what I think artists and composers, especially, we are trained to imagine. When you write an orchestral piece, you don't write it with the orchestra, right? You're imagining, you are using tools, for example. So it's not the best, or you could do it in the system, that would be amazing, but well, it gives us these opportunities. So encoding and decoding, that's like and basically these are two plugins, a plugin to encode and a plugin to decode. So we can see now here, this would be one of those plugins that it has all in one. So this first section would be the encoding. So I have a sound source, let's say a mono, somebody recorded a voice, and it's like this little dot. Sorry. And then I can move it, I can click in the little sound source and move it around the head of the supposed listener. I can see different views from up, from down, from the back to move my sound. The idea is that you would be like in the center of a sphere, right? And then you are moving the sound in the surface of that sphere. That's one way, or the other one would be like coordinates in the space. So that's why we have this Cartesian and polar, two ways of doing this encoding. This is really cool because spatial information is very important, the space. We get a lot of that information from the reflections and stuff. So this one comes with a reverb and some early reflections, so you can really create this impression. The sound is super far, 30 meters away, so the reverb grows, or if you want to put it 10 centimeters from your ear, all these changes. And at the same time, in the same plugin here, we have the decoding. So you here can choose the output format, and then you can choose, for example, binaural. Then we are combining systems, so Ambisonics, and then the decoding is in binaural. Or we can choose some film like 7.1.4, that would be like the minimum Dolby Atmos system, 9. Blah, 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 or Ambisonics, until third order of Ambisonics, that's kind of how many pixels. Imagine this sphere of sound. So if we are in first order, the thing is that we don't have too many pixels. If we are going up in the order, we are just putting more pixels, so it's just more defined. And that happens since the microphone can be first order, until going to the Eigenmic, but it's just so expensive, it's amazing. It has 64 little microphones in a bowl, but it's 20,000 euros, something like that. So, 12, okay, better. This is going down. that's really cool. So, cool. Now that I am talking a little bit about Ambisonics, so let's listen. Well, we already listened a little bit, but actually, don't put your headphones. We are only going to listen the speakers in this case. So I will put you this crazy piece to make this example. Just a little excerpt. Then we will listen the difference between the binaural. Cool.
Okay, let's start. Rule number 1, no whining.
Power of the system, right? With this, and then how we are surrounded. In this case, there was not too much movement. I was just using sounds, not to put just like the sound all around. Let's listen another little bit. will go a little bit before, just it's going to sound a little bit loud, and then you will hear like all the voices going around you, no? The voices. And then the big one just moving around. So with Ambisonics, we can create a lot of very cool ideas, but then we need a system. The more speakers, the merrier, of course. No, the first order would be only 4, but then you don't have the something very important for immersiveness is verticality. No, there are systems like 5.1, 7.1. They are amazing. They are surround, but they are 2D. You don't have verticality. That's also the difference between Dolby Atmos and not Atmos. No, you don't have verticality. That's the thing. With this type of systems like here is amazing because then we can move the sound up and down also, not only front, back, and being surrounded. So the second main technology, of course, is binaural. Ambisonics was kind of invented in the 70s based on, by Michael Gerson, based on the findings of Alan Blumlein in the 30s from England. He invented the XY stereo recording, the binaural. No? So binaural has been with us almost 90 years. But now is when as we are listening more and more and more with headphones, right? Because binaural, we can only listen in headphones. There is a way to put 2 speakers, but I think if you just do like a little bit like that, then it's broken. So it's really for headphones. And then in this case, we have 3 main differences when the sound is not coming from the center, right? The sound, if it would be the case, is arriving to this ear a little bit later with a little bit less volume and filtered by my head. That's kind of the shadow effect. So these 3 little differences are called the interaural cues, and that's what the brain measures. It's amazing, the brain, because it's really milliseconds, like the differences are really small, but that's enough for the brain to say, okay, the sound was there if this happens. And then we have this HRTF, the head-related transfer function, that is just the mathematical conclusion of this. So now we have a function, so if the sound is here, it should arrive with this delay, with this difference of volume, and with these spectral differences. Now, for example, the thing is that I am using a generic head-related transfer function, one size fits all, but you can do your own, because of course, for me, I mean, Sean has definitely more hair than me, the beard, the stuff, everything changes a little bit, so you could do a better head-related transfer function, or a specialized one, no? But then, binaural, in this sense, we can have a little bit more clear this sphere of sound, but as I was saying, is still not perfect. You cannot get this sound from below, for example, because actually I don't know how much time you think about the sounds that are coming from below. There are not too many, right? Normally everything comes from up the planes and stuff, maybe your steps, only maybe if you are walking above a river, then you get this sound. But I try already to do that, like if I would be walking, I cannot make it happen. It's not real, just, no? It doesn't happen. But, so, let's listen again, this beginning. Now there are going to be some differences between what was happening. There are some similitudes, no? There are some same sounds, but something different. So, but now we will hear the headphones. There is not going to be anything on the speakers. I will kill the speakers.
Okay, let's start. Rule number 1, no whining.
So it gives a very nice sense of space. We were listening some sources that I synthesize binaurally, let's say, but also, I don't know, these voices that were there is like I was walking in a market with this type of binaural microphones. You just put one and in the other ear, and then you can record like walkings and stuff. I really like it. Also, my niece, you hear like this little voice of a girl, like just doing that. I recorded with that to my niece. And then so it was kind of this combination, but creates a very nice spatial sense. Let's listen another example from the end of the piece where we hear this voice and this synthesizer moving around, for example. So also the same part as before. So it sounds, I think, really cool. And you heard like the difference from, for example, I didn't want to put all the bass of the beginning of the piece in here, send it to the headphones, and then it starts to being these kind of big differences, no? So also, guys, any question, please interrupt me anytime if you have any question. Everything cool until now? Super. Well, so this is being mainly the two technologies I'm using, Ambisonics and Binaural, that, as I was saying, they are not even new. But a very cool thing is that now with the new digital technologies, you can do this even for free. You just have your laptop, everybody has laptop and headphones, and then you can use a DAW like Reaper that is almost free. You can just evaluate it for 10 years or whatever you want. And then there are a lot of universities that created from research these plugin suites with all these Ambisonics encoders, decoders, delays, sorry, granulators, and they are for free. So actually there is no pretext to not do it, right? Because even, as I was saying, laptop headphones and this free software, now we can achieve that. And the early 2000s that this kind of started happening, it was all analog and it was really a little bit more weird. And so, well, continuing a little bit with this, I created these creative workflows because normally when you are composing or you are creating, you don't want to be dealing with the technical side, right? So I needed to have a kind of a clear signal flow every time, so I was free to compose and I was not taking care of that. Even though this thing about spatial music requires some technical issues and then you are normally, oh, I didn't send this correctly, so a little bit too much. But, so in this case, for example, the first one is that I can combine all the different types of sources, as I said before, so I can have mono sources, stereo, binaural, ambisonics, etc. Then I go to the process of encoding. I send it to an encoder. This will be the panner, again, just the 3D panner as we saw. I put together everything in a track called Ambisonic bus, and from here, then I do two sends, for the speaker bus and for the headphone bus. This bus is going to go, of course, to the digital to audio converter, straight to the speakers, and this one, I send it to the headphones. And an important thing to balance, like what we were listening at the beginning with the sine waves, know that this thing that how you perceive like it's going outside and inside, actually it's a very easy thing. You just move the gain between both, you can level them, and then if you just little by little, for example, remove the headphones, it seems like the sound is going to the speaker. If you bring them back, the sound is going again to the headphones. So a very simple idea, but that's super important in the creative workflow. And this, it was to bring some other music that is already there. For example, there are amazing pieces of electroacoustic music. Normally the standard it was an octophonic, 8 speakers around. There are tons of music written for decades in that system. But how can I bring it now like to an ambisonic system, for example, or even binaural? So there is a way you have your multi-channel sources here, and then you send it to one of each track for virtual sources. There is something called the multi-encoder, so you can put your virtual speakers, let's say where they are in the space, and then you just send the track or the source where it should be. You decode it to Ambisonics, and and you can recreate that. Of course, you are not adding, if there was nothing on the roof, you will not get anything, but then you can still now play these octophonic pieces, for example, in other places. So we have been doing some François Bale, Francis Dumont, Annette van de Gorne, some like classic traditional legends of the acousmatic music to bring them into the system, and also that is not only about me, right? And in this case, the rest is the same. The difference is this about the virtual speakers, but then you can get other type of mixes and bring them to the Ambisonics. Even a 5.1 mix, for example, then you can bring it also to Ambisonics. So for me, this was important to have these workflows since the beginning of the thing. Now, a little bit, this is more part of the academic thing that I need to prove that if this was really bringing a perception or the impression of more immersiveness, audio immersiveness, and that inside-outside the head. Of course, the hypothesis for me was just this sounds fucking awesome, but I cannot say that in the PhD, right? So I needed to prove it scientifically. So I developed this tool based on the International Telecommunications Union recommendation. Sorry, I think I missed it. Yeah, this is called the Mushra. That is a multi-stimulus test with hidden reference and anchor, blah, blah, blah. So this is the number. So this is a proven method to assess the audio quality of systems. That's how industry compares Yamaha 5.1 with an Onkyo 5.1. The codec for the phones, how to broadcast it better, no? So that was really a gift for my research, because then the method is there, I don't need to prove it, it's already proven, and then I can just go hard. And well, just this is like the tool, this is a guy doing the test. What you need to do is just these numbers here, there are different signals, it's the same music, but one, the full system, what we were listening. One without the headphones, one without the speakers. Different options, and also two crappy signals on purpose to then make the statistics, no? For example, so people just listening, boom, 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 grading with the faders, excellent, bad, just easy. And this is the best way to test things, not afterwards. Because if you do, for example, audience research, then you have to verbalize, you have to write what you experience. But if you test it and do it while you're experiencing it, you are bypassing that rationalization. So that's actually quite cool. And you need way less people. With this, you can do 12, 15 people, and with audience research, you have to do 200 to really draw statistic conclusions, no? And then, for example, the classic box plot, so I could the experiment gave me the idea that the hidden reference is the full system. It was the better grade from all, no? Of course, it has a median and the average, but well, somebody says 90 and stuff, and then the rest, not that much. So with this, I could prove that, yeah, the system, the hybrid audio diffusion system, brings the impression of more immersiveness. And I did two tests with the inside-outside the head. For me, also something very, very cool is that this mid-anchor and low anchor, the blue and the green one, are the crappy signals on purpose. Mainly they have a filter, so they sound a little bit like this, the signals. But they both have headphones and speakers. They were better graded than, for example, this impaired signal 2 that is only the headphones. So that was really cool, that even something like this, people preferred, or people perceive more immersiveness with both things at the same time. So this was really cool to prove that, yeah, this system brings this perception of more immersiveness and the inside, outside the head. So, well, these are the text conclusions about it. I wanted to show you that some applications, for example, so there is a acousmonium in Vienna. You know what is an acousmonium, guys? An acousmonium is a loudspeaker orchestra invented in the 70s by François Bale in France. It's like the place of the acousmoniums. And the idea is that you have all these speakers, but you see that they are all different. That's the idea. That is like an orchestra. You have clarinets, you have cellos, you have violins, you have different timbres, right? And in this case, yeah, this speaker sounds different than that one, than that one, than that one. And you can separate the sound just by the response of each speaker. In the center, you see this huge mixer. So you have per speaker one fader, the volume, and then you move the sound on the space, performing it with the mixer. So actually there was even, in Belgium, you can go and do a master's in diffusion with Annette van de Gorne, you know? And it's amazing when at the beginning they are moving faders. And when I was in a workshop with her, it's like seeing somebody playing Rachmaninoff. It's just really amazing what they can do. And it's a different concept. It's not good or bad, like with a dome in this case, but in here we have all the speakers are the same because we are creating the space within the system, right? In this case, the idea is to play and work with the space, not create it. So you can see even, for example, these speakers facing the wall, this one blue in the floor. So they are like very far, very diffuse. If you just send the sound there, you cannot really perceive where it's coming from. It's just like these diffuse things. Well, this is amazing. So this guy, the guy that is giving us the back, Thomas Gorbach, is the director of the Vienna Acousmonium. He heard about my project, about my system, and said, like, let's expand it with the Acousmonium. So in this case, for example, we built a cupola, like a dome, with these small speakers, with these gray ones, and in one fader, we can just put the full Ambisonics sound field, but then we still have all the discrete channels with the faders, so you can still perform. Then, for example, this is just to show you the back part, no? There was tons. In this case, we did 64 speakers. And this guy has crazy speakers like this. They look like a rocket launcher, no? These ones? Like these 8 little speakers, and these other ones, they are built by himself. So very, very nice. But that's the idea, that they are all different, for example. In this case, then we went full. So we built this dome again. We have this thing called the umbrella, no? Like these speakers on top of the people. We built the dome with the small gray speakers. But people has headphones, and then we put like these very far speakers. So it was really the first time that we could combine the headphones, the ambisonic sound field, and the idea of the Acousmonium having super far speakers. And it was a really great experience in this. These are water tanks in the Czech Republic. So it's 9 seconds of reverb. No? So like if you clap, you hear it for 9 seconds. It was a very, very interesting. And then, well, we have been playing, fortunately, this a lot. I have taken the hats to, I was just a couple of weeks ago in Portugal, in Lisbon, to Greece, in Slovenia, in Czechia. It's been great. This one was also a very peculiar system because they have more than 100 speakers. No? It's a system around 72 channels, but then you can see all these, they are called line arrays, like these lines of a lot of speakers. So they have kind of 2 systems within. It's a system that goes all the roof, and then within they have a sphere with these ones, no? That are these ones that are in the stands going around. So they have a sphere within, so it's like a taco within a taco. Okay, well, that's a South Park joke. So, and with the headphones, then in this case I did it with 32. But yeah, the last piece in the premiere, it was going to be in a big concert hall, so I needed to rent 100 headphones for everybody, and then wireless, because you can imagine this is already a lot of cables. Imagine 100, right? But well, there is a way. There is a 100 headphone amp that is around there, and then you can do these things. But well, so that's the only little detail that, yeah, technically it can be challenging. So well. Thank you very much. I don't want to talk, but we still have minutes to listen more, right? And then put questions, that's the point.
How would you rank the 100 wireless headphones? Was it like a silent disco?
For a silent disco.
Okay.
But it was not good. I have to say that because I needed open, more or less good headphones, and then I just choose the more open headphones they have, but they were kind of close. So it was a compromise. I know that it was not the best quality I could deliver in that sense, but it was the only way to get 100 headphones in a month, no, for the performance. But then little by little, that's why also this is super important for me, this project, because yeah, the idea it would be that little by little to build 100 of these, very cheap, and then I can have them in my bag and just move and be able to do bigger concerts, no, in that case. Sorry?
Couldn't those be Bluetooth enabled somehow?
Yeah, but also I am starting the project to research about this, to maybe get better the design with this and make them wireless, definitely. But Bluetooth is actually, I think, the worst kind of technology because it's too unstable. don't use Bluetooth for live things. Don't use it. It's going to flake. It's going to be flaky, and it's going to fail. But there is ultra wideband also with FM. You can even do FM like an FM transmitter, and then you just need to have the receiver, and that could be. We are researching about the FM. But yeah, this is the idea. Like when they designed it, is that yeah, I hear you perfectly, right? It's totally open, but yeah, maybe some little details can be better. But this is cool. That's why also we did this on Monday. This would be the way to get $30 instead of 200 per pair, right? And then little by little. The other way would be to get a sponsorship from Sennheiser or AKG, right? But I haven't write the letter, so I still need to do that. Any questions, suggestions? Please.
Probably the least interesting thing, but just the Mothra, your test that you did to prove your research.
Yeah.
That was a max patch.
That's a max patch.
How did you get the responses out and the usable data to get a degree?
Yeah, well, exactly. When you finish the test, you just press the button. Press when you finish the test, right?
Does that go into like a...
So it kind of gets all the information that you have, and it creates a text file for me. So with all the evaluation, the scores, let's say, and what was in every of these 8 signals, because I have a random button, so every assessor is different, because that was part of the scientific, like, because what if in the way they cross each other and one says like, number 3 is the good, like these kind of things. But so yeah, and under the hood, there is this ICST plugin suite also for Max MSP. So that's what we use. We don't have to invent it again, and that's what is running the Ambisonics behind the stage, let's say. But yeah, this is like also a research tool. I can share it with you guys if you want to do some tests. If it works for you, I can just share it. I mean, it's very specific, but I mean, you can do it for some other stuff. No, in that case.
Let's listen to something.
Let's listen to something. So I will put, I think, the double bass piece that it's like 8 minutes. Or do you prefer to listen snippets? No, I think let's listen the full piece, no? Or, well, the things that they are, okay. Let's listen to this. Whoops.
Well, great. I think we got to leave it there. Thank you so much, Enrique Mendoza. One more hand, please.
Yeah, thank you guys.
Thank you so much.